Welcome back to this day 31 of decision trees. We have had a brief introduction on decision trees. Today we are going to be exploring the words such as card, genie, entropy, regularization, and regression in decision trees. We have come across genie in a simple understanding, but we will go about all of these again. So, cart stands for classification and regression trees. Trees, we have seen the data structure which has a tree and a left and right node, or a two children node, which in decision tree language it's either a yes or no, or a specific class or no, right? So this way we also came across genie or impurity term, which gives us an information on how much uh, separation a specific class is having to hold in a specific tree node, right? Entropy is also a similar kind of a parameter. So in Genie, we measure if a node is pure or not pure. That is, let's say if there are 80% or 100% of A, then we say it's a pure node. This is also a pure node. This is of about pure node or so, right? So all of these come about these values, like what we see here. Okay, so that was a Genie, and it was easy to understand. Entropy, on another hand, is a word which is also used in chemical thermodynamics, which indicate the molecules that are not useful or disoriented to transfer heat. Similarly, here in entropy, there are impurities in a specific node, right? It gives the same meaning. So it has values something like this. It can also take up minus values also. So Gini and impurity are kind of a similar kind of parameters. So yeah, we can specify them with this parameter, but default is Gini, and we can also specify entropy like this. A graph looks like this for Gini and entropy. Train and decision tree classifier for iris dataset, and we can also visualize it for Gini, right? So here we see the decision tree classifier, which we have already seen previously as well. Okay, so we have also been able to read the decision tree, like here we see a Gini percentage of 38, 67, 67, which means one third is of versicolor and virginica when we consider Sentosa class. So that's where 66% is of impurities. Here it's 50% because both are of equal versicolor and virginica. Here if you see Gini is of very less because there is one amount of virginica also here. Okay, so that's about reading the tree, node and tree. Okay, now we are coming to regularization in decision tree. This is an important topic. We have looked at how underfitting and overfitting works in other models, SPN or linear regression or any other machine learning model. Similarly, here it's a bit of a difficulty to regularize decision trees, but max depth is one thing that we have already seen. These other parameters are also something that helps in tuning the machine learning model. CCA alpha, minimum sample split, leaf nodes, and all of these, right? So all of those are relating to decision trees regularization parameters. First thing is we are going to be looking at depths. So if you see max depths, as we increase, we are like overfitting the model to accommodate all the training data set. So that's one thing where as we increase the depth number. Here is a graph for the same. So ideally there should be a balance fit which is about 2, as you see here, to have best training accuracy and testing accuracy. Okay, so overfitting with nonlinear dataset, we are having to showcase it with some shallow tree, moderate tree, and unrestricted tree. Here if you see, um, with depth of 5 it is a moderate tree, right? And these parameters, minimum sample leaf and minimum sample split, when tree is making very small branches, like each features are being considered, we can consider minimum sample leaf maybe after depth of sixth or so. We can specify these values to control the way that decision tree branches out, which would avoid overfitting type of a model. Decision tree in regression is used for continuous values prediction, and it operates based on squared error, right? So here we have a simple decision tree with le- uh, linear tree regression model, and visualization for the same goes here. It's in simple visualization we can clearly see a depth of 2 has a higher regularization than depth of 6, which is more um, uh, which has higher training uh, training data set error, less training data set error, but looks like an overfitting to me with max depth of 6, right? So yeah, and we are also going to understand visualization or visualize for the max depths and the error values that we see for regularization regression a regression of a decision tree. Yeah, take a look at this. So that's one thing, and the same in chart. So tree instability, as decision trees have high variance, changing a small set of features also would um, change the way that the decision trees output or predict the value. So that's one thing to note. So this is one of the reasons that random forests are very useful. Okay, so yeah. Next set of things is decision trees expose feature importance, meaning that small set of features, uh, considering small set of features would increase overfitting kind of a pattern, while we need to always consider the features which are most important and balance it out. Cost complexity pruning, CCP alpha, is a parameter which helps in regularization or controlling the way decision tree classifier works. So that's one thing. So those were the few things in regularization. Those were the few parameters in regularization. These were the parameters, and these were the purpose of it, to control the regularization patterns with decision tree classifier. Strengths and weakness. Easy to understand, a decision tree nonlinear relationship captures feature interaction. Usually do not require feature scaling, works on classification and regression. Prediction is very fast. Weakness, can overfit very easily with depth value only having a greater control on high variance instability based on feature changes. Deep trees can become very large. Okay, so these were all the learnings for today. Hope you found this video helpful. Please do like, share and subscribe to my channel. Thank you.